Okay, so just walking you through kind of what is in this lab that you were assigned yesterday, and I get that the video wasn't really one of those where you had to fill in your own data. They actually provided you data in a separate file, so this was the data that they gave you. So they kind of already told you about the light blue for the lower concentration, the dark and the light blue but darker than the 0.1 molar, meaning that as you got more concentrated, you became basically you got more in the color. And then your 2 sodium chlorides both came out clear and colorless, which the lab questions kind of refer to that, and so we'll get there towards the end. So just kind of running you through what you had here. Basically, hopefully you read this whole description up here. It's kind of a review of what you've seen up to this point. And so it talks about something being sweeter versus not so sweet. And then they kind of give you this, your formula again, right? And so I just wanted to take a second to help out my people who are struggling a little bit with some of the algebra. You do have a triangle for this one as well, where you can say molarity is equal to moles over liter. And another thing I want to point out is this liter part. Okay, most of our measurements are given to us in milliliters. And so when I'm given something like 450 milliliters, I can easily change that into liters by dividing by 1,000, or you can take that 450 milliliters, take that decimal and move it 1, 2, 3 spots to the left to make 0.450 liters. Okay, and so you'll be able to use that in any of your calculations. One other part that I would like to point out was this mole part. Most of the time, just like in the labs that you guys had, we don't have a balance that measures moles. We have something that measures grams, right? So we have to be able to do that conversion between moles and grams pretty flawlessly, okay? And so in order to go from grams to moles, okay, in order to use it inside of the actual concentration, you would have your grams of solute, right, divided by the molar mass of that solute. Okay? And in order to go the opposite direction, so in order to go from moles to grams, you're going to take your moles and you're going to multiply by your molar mass of that solute. Okay, and so you're going to be using that throughout this video. So I wanted to make sure you guys had that first, so we'll kind of just tuck that off to the side. Look at this. So so the rest of this kind of had the different materials you're using. You didn't really need to do much with that except for, try to remember what all those little pieces of equipment are again. And yeah, so moving on. Page 2. So here, this is where we have those hidden questions as procedure number 1, and then we'll have procedure number 9 and 10 were also part of the questions. So I'll go ahead and take a second to walk you through procedure 1, okay? I'm going to kind of give us this space down here to work it out. So question number 1 is saying prepare 100 milliliters of a 0.1 molar solution of copper sulfate copper 2 sulfate, using water as the solvent. First, calculate the number of grams of copper 2 sulfate pentahydrate. So they give you the formula right here. Okay, and we are going to need to convert this from the moles that we're going to find into grams. So one thing that we are going to need is the molar mass of copper 2 sulfate pentahydrate. So the first thing that we can take care of is getting that molar mass by looking at our periodic table. So what you're going to do in your calculator is you're going to add together a copper, a sulfur, 4 oxygens, and then you're going to have 5 waters, right? 5 waters. So let me just put the whole thing here. So we've taken care of this whole part by adding those together, times 4. And now the 5 waters. So if you remember, water is about 18.02. So 5 times 18.02, you're going to add that to the molar mass of copper 2 sulfate. So when you add all those values together, you should be getting the number 249.708 grams. Okay, 249.708 grams. So once again, what we did was we added copper, sulfur, 4 oxygens, plus 5 times the molar mass of water, 18.02. And so your molar mass for this copper 2 sulfate pentahydrate ended up being 249.708 grams. Okay, so we need this for this calculation. So they give you the information that we have a 0.10 molar solution. We know that the calculation itself is molarity is equal to moles over liters. So we know that we got to solve for moles. Liters, they gave us 100 milliliters. So we're going to take that 100 milliliters. We're going to take the 100 milliliters, remove that decimal 3 to the left to get it to be, 1, 2, 3, to get 0.100 liters. Okay, so 0.100 liters. So in order to solve for this top value right here, the moles, we're going to take these two and we're going to multiply them. We're going to multiply the 0.100 out. So when we do that, you end up getting 0.01 moles. So our next step, because we want to know how much of this copper 2 sulfate we have to measure out of the little bottle, we're going to take that and we're going to multiply it by the molar mass. So 249.708 grams. When you multiply those two together, kind of zoom out a little here. When we multiply those two together, we're going to end up with the value of 2.497 grams of this copper 2 sulfate. Now looking up here, it was pointed out in the Zoom video earlier that this only has 1 sig fig. I don't want you to round all the way up to 1 sig fig, so we're going to actually go to 2 sig figs. We're going to respect this one, okay? So we're going to go 1, 2, check the one behind it, so we end up with 2.5 grams of copper 2 sulfate pentahydrate. I apologize, that one looked not like a 5, it looked like a 6, so let me make it look like a 5. There we go. And that would be the first answer, so for number 1. Okay, so moving on, 9, we have follow steps 2 through 8. So I do want you to read through the procedures just so you're not totally forgetting how to run a lab. Okay, and number 9 is saying follow steps 2 through 8 to prepare 100 milliliters of a 0.5 molar solution of copper sulfate. Now, if you already turned it in and you turn it in as copper 2 sulfate, that's fine. But what I would like you to do, if you're just now doing it, is what they should have said was copper 2 sulfate pentahydrate again. They were talking about the same solution, because the whole point of this is so that you can see that difference in the amount of solute that we had to put in order to prepare this solution, right? So for number 9, we're going to be following the same exact process, okay? So we have 0.5 molar solution is equal to moles over, we have 0.100 liters, okay? Now, one more time, I would like us to go to 2 sig figs. Please don't round all the way. I think on this one you're rounding down to 1 sig fig. So I don't want you to do that. I want you to go to 2 sig figs. Okay, so when we have that, once again, we're going to take these two, multiply them, okay, to end up with 0.01 0.05 moles. We're going to multiply that by the molar mass, which was the 249.708 grams, to get 12 grams of this copper 2 sulfate pentahydrate. Okay. So looking between your answer on the last one versus this one, we have 2.5, so 0.1 required 2.5 grams. 0.5 molar requires this 12 grams. So you can definitely see a huge difference in the amount of solute that we're putting in, okay? So that's it for number 1 and 9. Those were very similar questions. Okay, so moving on to number 10. So number 10, we says prepare 100 milliliters each of a 0.1 molar and 0.5 molar sodium chloride solutions using water as the solvent. Record your detailed procedures as well as any materials to be used. So this is truly based off of your notes that you took on Thursday. There was a short 2-minute video that I asked you to just take notes over how to make a solution. And so just a couple of reminders before we start writing this out. When you are creating a solution, remember that it involves that you have a solid that you're going to measure out. So you got to measure it with the weigh boat on the balance, right? You're going to put that into a volumetric flask. So I think that they had in both videos, they kind of showed you what a volumetric flask is. But what it is it's a very fancy flask that has an etched line, okay, so a fill line. And basically each one is very specific to a certain volume. So this one would be like our 100 milliliter one because that's what they're asking for. And so the only amount that it can measure is 100 milliliters. There's only one line on this volumetric flask. So this is a volumetric flask. Once you put it in there, now we have to use our little DI water bottle, right? You guys remember those? Okay, and you're going to use DI water to fill it up to that fill line, and then you're going to put a little stopper on it, and you're going to swish it back and forth. So that's the basic instructions, and those are the procedures that I want you to show me. However, before you can even write those kinds of procedures, you also have to calculate a little bit on this one. We change what substance we're talking about. So our solute is now going to be sodium chloride, which means you need to refer to your periodic table again. And so your molar mass for sodium chloride is going to be 22.990 plus chlorine's molar mass, which is 35.453. When you add those together, you end up getting a molar mass of 58.443 grams per mole. Okay, so now that we have that, now we have to actually figure out how much we would be weighing out. Okay, so we would have, once again, our 0.1 molar is equal to moles over 0.100 liters, which will just make it be 0.01 moles for the 0.1 molar solution. And then we have 0.5 molar solution, and we're going to have moles over 0.100 liters again to get us 0.05 moles. So for both of these, with the amount that we have, we're going to have the same number of moles of solute in them. Okay, so next, now that we have that, okay, that little piece of information, so move that off to the side over here. We'll just move down there. All right, now we actually have to talk about how much we're measuring out. So just like we did in the previous examples, you're going to take your 0.01 moles. We're going to multiply it by the molar mass, which is now that 58.443 grams. Okay, and we would end up getting, for our first set of procedures, so I'm just going to go ahead and start writing those procedures out. Measure / weigh out the answer to this, which would be, type it in, 0.59 grams of sodium chloride, and transfer, which means dump it in, to a volumetric flask. Number 2, add DI water to the fill line of 100 milliliter volumetric flask. And then the last part would be, so the ending part of this would just be cap the flask and invert 10 to 15 times. What that means is just kind of swish it back and forth, holding the stopper in place. And that's it. So your final procedure would then be repeat steps 1 through 3 using, and now we need to know that other amount. So now we have the other amount, which is 0.05 moles. So we're talking about the 0.5 molar sodium chloride solution. So 0.05 moles times that molar mass of 58.443 grams, and you would end up getting 2.92 grams of, so 2.92 grams of sodium chloride.